Alright, in this video, we're looking at using the equation of a circle. This is my second video over this, and this is really just varied types of problems. These problems don't all follow a particular structure or type, but we are just getting some work with, with knowing how to use the equation of a circle. So in this first problem, it gives that the points 0, 5, and 0, -5 are the endpoints of the diameter of a circle, and the point 3, y is on the circle. What is the value for y? And so first let's use the information that we have. They give us that the points 0, 5 and 0, -5 are on the circle. So 0, 5 would be there, and 0, -5 would be there. Okay? And then what we can deduce is that would mean that the center of the circle must be our origin, and that other endpoints of a diameter could be 5, 0 and -5, 0. So now, with that information, I can get a rough sketch of what our circle looks like. So let me draw that circle real quick. And it's not perfect. I missed some of those points a little bit, but that's a pretty good circle that's being described right here. Now, it tells us that the point 3, y is on the circle. That means it's a point with an x-coordinate of 3. That means it's going to be somewhere on this line, on the line x equals 3. And so there's really two solutions to this. You could have the point 3, 4, or you could have the point 3, -4. Okay, that y-coordinate could be 4 or -4. There's two solutions. Now, that's kind of the easy way of doing it. We looked at it graphically. Let's look at this algebraically. Okay? So we're going to actually write the equation and solve. Okay? So if I know, well, first off, let me write out the equation of a circle. We got x minus h squared plus y minus k squared equals r squared. So algebraically is good. For one, we need to be familiar with this equation of a circle, but two, our numbers turned out really nice and pretty in this problem. 4 and -4. You can look at the graph and tell, but what if it was some decimal? We would need to be able to solve algebraically to figure out where exactly that is. And so, if I know the radius of my circle, which in this case is 5, you could graph that to see it, or you could just figure out, okay, if I have one endpoint of the diameter at 5 and one at -5, that means there's a diameter of 10. So halfway there would be to the center of the circle. It would be the radius of 5. So hopefully you can kind of figure that out by just visualizing what this looks like in your head. And then the center of the circle, once again, is 0, 0. So actually you could write it like this to kind of follow the form of these. Your h is 0 and your k is 0. And once you simplify it, x minus 0 is just x and y minus 0 is y. So here's the equation of our circle right here. And so if we wanted to solve this algebraically, what we have is we have the point 3, y. And we're saying, okay, how can I determine the y value when x is 3? And so what you could do is you could just substitute 3 into your equation and solve. And whenever I solve this, I should get the 4 and -4 that we got from our graph. Let's see. 9 plus y squared equals 5. Then I'm going to, something was about to go wrong there. I almost forgot the squared on my 5. So then 5 squared would be 25. So if you subtracted 9 from each side, you'd have y squared equals 16. If you solve that equation by taking the square root of each side, you get that y equals plus or minus 4. So we got the same solution algebraically as we did graphically. Let's do one more problem. Find the equation of the circle with a center in the first quadrant and it's tangent to the lines x equals 2, y equals 3, and x equals 8. So let's kind of draw these lines. So I'm going to draw x equals 2 first, and what that's going to be is that's going to be a vertical line through 2. And I'm just going to deal with the first quadrant because our center is going to be in the first quadrant. Then let's graph y equals 3. That's a horizontal line through 3. And then lastly, let's graph x equals 8. That is a line through, let's see, 2, 3, 4, 5, 6, 7, 8. So here is our situation. So it says it's tangent to each of these three lines. It's going to touch this line, it's going to touch this line, it's going to touch this line. And so you might think, okay, well our circle could be down here, but it said its center is in the first quadrant, and that center looks like it's probably going to be on the x-axis. So what we're dealing with is we're dealing with a circle that is here, okay? You can tell by looking at it that this distance, this distance from there to there is 6 units, so our radius must be 3. So if I come up 3 from there, over 3 from there, over 3 from there, you can find the center of our circle, which is going to be that point. And then as I mentioned, we could just get a drawing of it to see what it looks like. And that's going to be our circle, okay? Now let's identify what that center is so we can write the equation. The center of that circle, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Looks to me like the order pair 5, 6. And it looks like our radius is 3. Now with that information, that's everything we need to write the equation. We know that our equation of our circle is x minus 8 squared plus y minus k squared equals r squared. So that would be x minus 5, because h is the x coordinate of our center, plus y minus k, and k is the y coordinate of our center, and then r is 3. So I could leave that as 3 squared, or I could write that as 9. So I like this question because you have to use, you can kind of visualize it graphically, but then come back and represent the equation algebraically. We're kind of bringing all of our knowledge about circles back together. So yeah, that concludes the video. Just a couple of kind of, I don't want to say random, but kind of mixed up problems type you might see on dealing with equations of circles.